Hey guys, welcome to my channel. Welcome to another video from this series of videos that we're doing to bring the learner up to speed in terms of networking, networking technology, and just getting the experience and exposure that you need as you seek to establish a career in this field. So today we're going to talk about um, routing, and in particular, we're going to talk about um, a routing protocol, which is OSPF. This is just very introductory. I've actually presented here a topology. It looks complicated, but it's really not. It's very simple. Once you understand it, you will realize how simple it is for you to work through it. Right? I am a little bit under the weather. Been under the weather for a couple of days now, but I figure to get my mind off things a little bit, I'd just try to hop out of bed, do a little recording here, share it with share it with you guys, so that if you do have the urge or the need or the desire to learn more about this topic, you can always just dive right in and work through it. All right, so just a few little notes here. Of course, you'll need to do a little bit more reading to get all the intricate details about OSPF, but OSPF means Open Shortest Path First. And, we've actually looked at routing before, and the routing that we looked at was static routing, right? So static means manual. You're going to add a route, you have to manually put it in the network. You're going to remove a route, you have to manually complete the configs, right? With dynamic routing, what it allows you to do is to automatically distribute the routes across your entire network without having to touch every router that need to participate in that route, right? So with a static route, in this case, if I were going to add a static route, and let's say the static route, I'm just going to make it up, right? Where I'm going to add the static route 7.7.7.7 slash, say, 32. And I'm going to add that on router 1. If I'm using the static route approach, what I'll have to do, I'll have to go to router 2. And if I go to router 2 up here, right, I'd have to, let me see if I could find my little pencil here. I'd have to add a route manually that says, hey, to get to 7.7.7, point it over to router 1. And the same thing I'd have to do on 3 to get to 7.7.7, point it over to router 1. But in addition, I'd also have to add a route on router 2 to say to get to 7.7.7, point it over to router 3, right? That means if the link between router 1 and router 2 were to go down, it would still know how to get it, right? Because it would just take the reverse path. That is going to router 3, and then from router 3 up to router 1, right? So we're going to show you how to still achieve all of that without having to do it manually, right? So just get ready. All right. So one of the first things that I'd like to do, if you know notice the network here, just for troubleshooting purposes, here are the networks that I'm using. 192.168.120/24. So this is router 1, this is router 2. All right. So the 1, 2 here is just saying, just representing the link between router 1 and router 2. And the same thing down here, router 1 and router 3. I'm using the third octet to identify it. Subsequently, the same thing between router 2 and router 3. When you're learning, it's kind of just makes it a little bit easier for troubleshooting. So that's why I do it like that. Okay. But there's really no specific reason why you have to use this. Right? We're not really going to get into subnetting. That's why I chose to go this way. So let's jump in here and let's get over to our router 1. Right, these are brand new routers. I just turned them on, haven't done anything yet. So I'm going into global config. I'm going to change the host name. The host name is R1. And I am going to get into my interface gigabit 0/0. And the first thing I'm going to do is no shut it, right? So I just no shut my interface here, and that is the interface leading over to switch 1 of the local area network on this side, right? Um, so there we go. And I could actually configure the IP address while I'm there right now. I thought I wrote it in already, but it is not showing up here. So let's kind of just write that in right now. The IP address that I'm going to use is 172.16 with 0.0/24. Okay. So in this case, I am going to use .1 on the interface for the of the router. So on gigabit 00, I'm going to use .1. So I'm already in gigabit 00, right? And that's the interface of the router that's connected to the local area network. And what I'm going to do is just to assign the IP address there. So to do that, I go IP address 172.16.0.1 255.255.255.0, and I do no shut. It's already done, and I could just do WR, which is the same thing as coming to privilege exempt mode and type copy run start. Right? So do WR is just an alias for saying copy run start. Right? All right, so we've done that. We've done that right now. And the other thing that we need to do is to configure. Let's turn up the two. Let's go in and turn up all our serial interfaces, right? So again, we're going to do that. I'm going to get my pointy tool up here. I'm going to come in router 1, go to the router 2, go to the CLI, do no, hit enter, config T, do enable serial 0/3/0. And I'm going to say no shut, interface serial 0/3/1, no shut. And I'm going to do, let's see, gigabit 0/0, 0/0, all right? And I do no shut. And that's actually connecting to the LAN 1010 0/24. So that one is going to be configured on this interface. So here I'll go in a gigabit 0/0. IP address is 10.0.0.1 255.255.255.0. And I'm going to say no shut and bring that online. Okay. Again, do WR is just a short for saying copy run in config to startup config. That's what we just did. And I will go over to to router 3. And on router 3, I'll do the same thing. Let me just click that so it comes in top. I'll go no, and I'm going to go into enable config T. Host name is router 3. I'm going to say interface serial 0/3.0, no shut, interface serial 0/3/1, no shut, and that's also up. Notice the interface between serial 3.1 and serial 3.1 over here is up. Notice it's not up between router 1 and router 3 yet. So if I go over here, let me just click on for it to stay on top. If I go into config T, interface serial 0/3/0, and I say no shut, all right, so that means serial 0/3/0 is actually the interface that's connecting router 1 and router 2, right? So we know if that's the one that's connecting router 1 and router 2, then we could just assign the IP address, which is 192.168.12.1 255.255.255.0. All right. And now I also know that serial 1, right, 3.1. So if I say interface serial 0/3/1 and I say no shut, I know that's the interface that's connecting down to router 3. I could actually put a description and just say connection to R3. So if I'm troubleshooting and I need to know what it is, I can easily figure that out. And here I am assigning the IP address, 192.168.3.1.255.255.255.0. So I'm good here. Actually, I could go ahead and take a look at my configs on router 1, and I could do show IP interface brief, exclude unassign. So I'm saying I want to look at all my IP addresses that are configured on the interfaces, or I'm looking at the interfaces, and all I want you to give me information for are the interfaces that does have an IP address configured on it. And I see there are 3. So gigabit 00 is the one going to the LAN. All right, serial 030 is the one going to router 2, and serial 031 is the one going to router 3. So I see that everything looks good here on router 1. All right, let me go over to router 2. So if I go back to router 2, I could now go into interface serial 0/3/0, and I know that's the interface that's connecting me back to router 1. Again, good practice description. I could say connection to router 1, and then I assign my IP address 192.168.2.255.255.255.0, and we're good. I could do show IP interface brief and 6, right? Exclude unassign. So that's what I just did. I just say show me the IP address configured on each interface, but show me in a pretty much show IP interface brief and exclude all interfaces that do not have an IP address configured. If I were to take this off, it would show me interfaces with IP addresses configured. That's this. Interfaces with no IP addresses configured. That's these, right? But I didn't want to see it. I want to see a more concise version. That's why I put the pipe exclude unassign, right? Note that this is also case sensitive. All right, so the next thing that we need to do is to configure the interface between routers 2 and router 3. So it seems like serial 031 is the interface that's connected between router 2 and router 3. So I'll go into interface serial 0/3/1, and I'll assign an IP address, which is 192.168.23. I'll just do 2.255.255.255.0, and it's already up, but it's just habit that I just type in that. And if I go back and do show IP interface brief, and I do exclude unassign, it shows me the interfaces that are configured with IP address and their status. The protocol is up, and the line interface is up. Okay, guys. Now, let's get down to router 3. Router 3 is up here already. We haven't configured anything in router 3 yet in terms of IP. I don't think so. If we do show IP interface brief, right, there's nothing there. So what we need to do is configure the interface that's going up to serial 0301. So let me go into interface serial 3003/0, and if I do shut just to confirm, okay, no shut. So now, like with confidence, notice what I did here, guys. I actually did shut because the labeling is kind of skewed, right? So when I did shut, I see the interface up here. Let me get my pencil. I see the interface up here that is associated with router 2. It went offline. All right. The moment I did no shut, I saw that it came back online. So I can definitively say that serial 030 is the one that's connected up to router 2. So I could actually put a description here and say connect to router 2. And in here, I could put the IP address 192.168.23.3, 255.255.255.0. Again, no shot. I don't need to do that. And then interface serial 0/3/1. I could put the IP address 192.168.13.3.255.255.255.0. I want to call this to your attention. Again, just for troubleshooting purposes, notice the router number is equal to the last octet, right? So in this case, both the interface that's connecting up to router 2 and the interface that's connecting over to router 1, the last octet of the IP address, I just keep it consistent with the router number. Again, just for easy troubleshooting. And the same thing I did over here. Notice the interface, the IP that's configured on serial 031 on router 2 is 192.168.23.2. I'm keeping it consistent with router 2. And the same thing over here, dot 2. I'm keeping it consistent with router 2. And over here, everything is dot 1. Okay? So that's what we see going on there. So now it seems as if I've configured all my IP addresses. And one of the things that we could do, we could kind of just test layer 3 to make sure that we have layer 3 connectivity across the entire network. How can we do that? If we go on router 2, we should be able to ping router 1 and router 3. Okay, so let's take a look. If I go into privilege exempt mode and I type ping 192.168.12.1, notice I'm on router 2. So if I 12.2 is the local IP on router 2. So if I ping 12.1, I would be pinging router 1. And I see that router 1 ping, it was successful. And if I go here and did the same thing, 192.168.23.3, I'm sitting on router 2, as you could see up here at the top, right where I'm pointing to my mouse, and I could ping router 3. And I'm pinging router 3, right? And matter of fact, notice I left this at the default, so I need to configure it. I go to host name R2, right? And again, we just do save. Now, if I go over to router 3, I could do the same thing. From here, I could ping 192.168.13.1. That's pinging router 1, and I could ping 23.2, and that's pinging router 2. So I know that I'm all configured and everything is good. Everything is happy. So let's go in and just start configuring our dynamic routing protocol. But before we do that, let's assign IP addresses to the PCs. I'm going to use .10 for both PC. So in this case, I am going into the PC. I go into IP configuration, desktop IP configuration, and here I am typing 10.0.0.10, and the subnet mask is a /24, right? And the default gateway is the IP address that I've configured on the interface of the router. So that's 10.0.0.1. Now, if I go validate from my PC, I'm on PC2, I should be able to ping gigabit 00 on this router. The IP address that's on gigabit 00 as we configured it, and we know it is where is my pointer? It is .1, right? So let's do it. .1, right? So let's validate that we can ping it. So here I should be able to do 192.1. I'm sorry. I should be able to ping 10.0.0.1, and I'm pinging, so I know that I could ping my default gateway. Note, by the way, if I ping 192.168.12.2, which is the interface on router 2, the interface in serial 030, right? And we know that it's 192.168.12.2. If I ping that, it will work, right? It's coming right back, no problem whatsoever. And I also know that I ping, the interface that's on serial 031, 192.168.23.2, it will work. 192.168.23.2, it will work also. However, if I ping .3, I know it won't work. Why is it not working? Dun, dun, dun. All right. So I know someone is trying to answer, but I can't hear you. So let me explain. Right here. And I'm going to also explain and I'm going to show you. Here's what's happening. This PC here is configured with the default gateway. So the PC is using the ending process to know when to broadcast, right? That is, shout, or when it needs to send the packet over to the default gateway. In this case, it is saying, hey, this is on a different network from what I'm configured on. So it says, let me send the IP over to my default gateway. The default gateway in this case is 10.0. All right, this is not good. .0.0.1, and it gets it. When this gets it, it looks and it says, okay, 192.168.2.2 is local here. So it says, okay, I see that a ping is coming in for me. I need to respond to the machine that's generating that ping, and that is 10.0.0.10. And it says, okay, let me check my routing table. And it says, I know how to get there because 10.0.0.0 is a locally connected network, right? We could actually go in and take a look at it. If we go on the router over here and we say do show IP route, right? I can see that 10.0.0.0/24 is a connected route. We're identifying that by the C that's here, right? And we also know that 10.0.0.1 is the IP address that is configured on gigabit 00 because we're seeing all of that right from the show IP, right? So it knows, so when a request is coming from 10.0.0.1 going to 192.168.23.2, which is the local IP on serial 031, it knows how to get back to it. However, if we send it over to router 3 like we just did, we might expect a different result. So let's go in and take a look. So if I were to go here and do show IP route, if I do show IP route and I look, it says, hey, Norwin, the only networks that I know about, and here I'm marking this up so you could see it, the only networks that I know about are two connected networks. See? We're identifying those by the C. They're 192.168.13, which is the network that's connecting it back up to router 1, and 192.168.23, which is the network that's connecting it back up to router 2. These are the only networks I know about, Norwin. So I know I saw a ping earlier that's coming from 10.0.0.10. I get it, but I don't know how to get back, because for me to be able to to send the response back, I need to know how to get to 10.0.0.0/24. And Norwin, that's not in my routing table. So I'm sorry, Norwin, I'm going to have to drop the packet, and boom, it drops the packet. That's why when we pinged over here previously, notice when we pinged this, we had all packet loss. Right? Let's do it again and show you. All packet loss. Because it doesn't know how to get back there. I'm going to go a little bit deeper. Right? We're already 23 minutes into this nugget. Oh my God. Didn't realize how time is flying by fast. I guess I'm having too much fun. All right. So I'm even going to go a little bit deeper and do a debug. So on router 3, we're sitting right now on PC2. And we're trying to ping this interface here on router 3. So I'm saying to you that the packet is going this way. It's going through router 2 and it's getting down here. However, the source network that it's coming from is 10.0.0.0/24. And if you look in the routing table here, it doesn't know how to get there, man. And there's no net gateway of last resort set. Right? So it doesn't know what to do. So I'm even going to demonstrate that, right, to show you. I want the theory to match what we're doing in the hands-on, right? So let's do that. So let me come over here. I'm going to do debug IP packet. Guys, you have to be very careful with debug, right? Debug can crash your router. Right now we're in a lab, right? We're practicing. We don't care. It's not going to bring anything down. So all we're doing is we're turning debug on. So let me go back and do the same ping. And now we're actually confirming everything that we talked about. Let me stop the ping. I'm going to let it ping one more time, and then I'm going to stop it. So look at what I told you router 3 was going through. Router 3 was saying, hey, the source, I got a packet, and the source that it's coming from is 10.0.0.10, which is the IP address of my PC. And it's saying, hey, it's actually destined for my interface, which is 192.168.23.3. And it's saying, hey, that's actually configured on serial 030. But now it is saying, hey, I'm trying to reply. You know, this PC is calling out to me. And now I'm trying to reply because notice, you see here, that's the reply. Because now I become the source, right? So this is local. And it's trying to send it to the destination IP of 10.0.0.10. So it does the end in process. And after it does the end in process, it looks and it realizes that, hey, by the way, I don't know anything, right? You know, this is going to be a remote network. And I need to send it over to 10.0.0.10. But I look in my routing table and I don't see anything how to get there. So it says, hey, the packet is unroutable, man. And if the packet is unroutable, all it has to do is drop it. Right? So let's correct that now. And the way we're going to correct it is by using OSPF. So let me clear this out and let me just go in and configure our first OSPF neighborship. So let's start with router 2, right? So on router 2 over here, we're going to get over to router 2. So to configure OSPF, we type router OSPF and we give it an instant number or a process ID. The process ID can be any number, right, between the number of 1 to 65,535. The number is only locally significant. So it can be 1 on this router, it can be 1,000 on the other router, it could be 1,357 on the other router. Who cares, right? I'm just going to say router OSPF1. That's the process ID. And inside here, notice one of the things I told you guys about. Each router needs to have a unique ID. Well, how does it select the ID? It selects the ID by assigning the highest available IP from any physical interface as the router ID. Now, if there are IP addresses on physical interfaces and or on loopback interfaces, it will take the IP address of the highest number, right, of the loopback first. So if you have, let me see if I could, say this in English. If I have loopback 1 and loopback 1 IP is 10.10.10.57. I'm just making these numbers up. And I have loopback 9 and loopback 9 is 100.57.67.8. And I have physical interface, let's say gigabit 0/0, which is 197.24.52.3. Well, and then I have another one. I'm going to just complete the job here. Gigabit 0/1. And this is 203.54.3.2. Now, if these 4 interfaces were configured in my network, right, now the process, here's how it works. The process by which the router ID is going to be selected, it's going to be the highest numerical value of the loopback interfaces first. So in this case, loopback 9 would win because the numerical value 151.57.8 is higher than 10.10.10.57. If 9 were not there, then the router ID would be loopback 1. Because even though you have physical interface gigabit 0/1 and gigabit 0/0, they do have a higher numerical value. Loopback are preferred to physical. If there were no loop back there, then the router ID would be gigabit 01 because it's a higher physical numerical value than that of gigabit 00. Is that clear? All right. I hear you all saying, yeah, it's clear. All right, good. But you don't have to do that. You could actually now hard code what you want for your router ID to be, and that's a more controlled way. So now notice we're in the router OSPF, the process ID 1, and once we do that, we're in global config, right, when we executed this command. And look, we're in routing context right now. So now I could say, router ID, and I'm just going to say 2.2.2.2. Easy to remember. Now, what I am going to do is show IP interface brief, and I'm going to say exclude unassign. And what I will just do is introduce all of these interfaces into the OSPF routing process because I want it to participate in routing. We'll show you what you need to do if you do not want them to participate. You want them to participate in routing, but not necessarily form a neighborship or send out neighborship query. So let's do this. So now I could go here and I could say network 10.0.0.0 255.255.255.0 area 0. Right? Area 0, by the way, is called the backbone area. And all areas in OSPF have to touch the backbone area. Right? Let's go back and say network. Let's type it all out. 192.168. Before we go any further, let me show you. Do show run. And then I say section OSPF. Notice what I typed in. When I typed in, I'm introducing network 10.0.0.0 with a subnet mask 255.255.255.0 and area code 0. And look at what it does. Right? It wrote in the inverse. Right? So it's using the wildcard mask. In older version of the operating system, I would have to manually type the wildcard mask in. Right? But in the newer version of the operating system, you do not have to do that. It will calculate it automatically for you. All right, so let's and also if you type the IP of the physical IP of the IP address, it will still convert it to the network ID. So in this case, we used the network ID, and what it did, and we used the subnet mask, and what it did, it still used the network ID and converted it to the wildcard mask, right? So in this case, let me just say network 192.168.12.2, and I'm going to use the wildcard mask 0.0.0.255 area 0. Same thing. We could do show run section OSPF. Now you see, end result's still the same. And we'll just do network 192.168.23.0.255.255.255.0 area 0. Right? So now we just configured everything that we needed to configure on router 2. Now let's kind of just rinse and repeat over on router 3. So on router 3, we're going to do the same thing. Let me click this so it comes to the top. And we're just going to do this. We're going to do config T. We're going to do router. Oh, by the way, look, you see, because we have just configured router 2 for OSPF, what it starts doing, it starts sending out, neighbor hellos. And it sends these neighbor hellos out, every 10 seconds and say, hey, I want to be your neighbor. I want to be your neighbor. Do you want to be my neighbor? I want to be your neighbor. Do you want to be my neighbor? And look at how it's sending it out. It's sending it out on multicast IP 224.0.0.5. 224.0.0.5. So router 3 is saying that I'm receiving them. But if I were to go on router 3, I'm sorry, router 3 is saying I'm receiving them. If I were to go on router 2, notice router 2, if I were to turn on debug here, debug, there are just too many things going on in my mind. Debug IP packet, right? I'm going to see that it's sending it out, right? Notice it's sending out, right, the multicast broadcast. It's sending them out, but it's not receiving any, because notice it's saying sending, sending, sending. And notice over here, router 3 saying receiving. Let me kind of put it here so you could see. So we're sitting right now on router 2. We have configured OSPF in router 2. So router 2 is saying, hey, you know, a neighbor, I want to be your neighbor. I want to be your neighbor. Do you want to be my neighbor? But because router 3 or router 1 is not configured with OSPF yet, it cannot accept and say, yes, I want to form neighborship with you, right? So notice router 3 is receiving, right? Because they have to mutually agree. So router 3 is receiving, router 2 is doing the sending. But I want to bring your attention here, you all. That's how we did. We're turning off debugging right now on router 2 because I want to slow down and show you something. Notice router 2 is sending OSPF neighborship request on gigabit 00, on serial 31, on serial 30. But if we look at the topology, it will never be able to form neighborship on gigabit 00. Why? Because there are no routers there. There's no neighbor there. But it doesn't stop it from sending out the broadcast request, right, on multicast 224.0.0, right? So it's just flooding your network unnecessarily because you're sending a request to form an OSPF neighborship to a device that will never form neighborship with you. All right. So if we go show run section OSPF, we'll see it there, right? So how do we stop that, guys? We could actually go router OSPF1, and we could say we could say passive interfaces gigabit 0.0. So what does that mean? It simply means that, so I'm going back here, do show run section OSPF. It simply, what did I do here? Do show run section OSPF, right? It simply means that, notice the IP address that's configured on that interface, 10.0.0.0, right, with a class C subnet mask /24, it needs to participate in the OSPF routing process. That is, I want this network to be broadcast to neighbors so that anyone on the network knows that needs resources from this network know how to get there. However, this passive interface is saying, please don't send hello requests on this interface out to a neighbor because there are no neighbors there that will ever form OSPF neighborship with it. So don't waste your time, don't waste the resource sending it out because it will never form OSPF neighborship. And we can go back and we could say debug IP OSPF, debug IP packets. And once we do that, we'll still see it sending out neighborship hello, but notice it's no longer sending out hello requests on gigabit 00. All right, notice it's only sending out hello requests on serial 31 and 30, right? And that's exactly what we want. All right, good. So we're rocking and rolling here. You all, I'm going to turn off debug. So let's get back over here on my router 3. I'm going to also turn off debug because it gets quite noisy. So if I do show run section OSPF, all right, so let me get over here now. And what I'm going to do show IP interface brief, exclude unassign. All right, so now I'm going to say router OSPF 1, router ID 3.3.3.3, network. Network is 192.168.23.3, 255.255.255.0, area 0, and we do network 192.168.13.3, 255.255.255.0, area 0. And by the way, look, it formed neighborship already. It says, hey, I just formed neighborship with a router with router ID 2.2.2.2, right? So if I were to go here and look, what I could do is show IP OSPF neighbors, right? And I see that neighborship was formed. Neighborship was formed, man. And because neighborship was formed, if I go over here now and look at router 3, man, I'm totally excited. So if I go over here and I look at router 3, show IP route, look at the difference now. It says, hey, Norwin, I did learn about a network 10.0.0.24. Look at the administrative distance, 110. And it says, man, I learned about it by way of OSPF. You see the O here? It tells you that this route that's injected in the routing table was learned by the OSPF routing protocol. How do we know? We can see it here. So C means connected. L, right, it's the local interface of that network. O is OSPF, and when we're doing EIGRP, we'll see D, so on and so forth. So, these are just the codes that help you to identify what's going on your router. Groovy. All right, so now remember when we were on PC2 and we were trying to ping 192.168.23.3 and it failed? Now, if we go back and do that, it says, hey, I will no longer fail because I know how to get back to the 10 network. So it will no longer say, unroutable, because it's not going to be unroutable, man. It knows how to get to it because it's in the routing table. And what we have to do over here now is just go over to router 1. And once we go over to router 1, we do the same thing. Config T, router, OSPF. Hey, I'm going to make it a little bit different because remember I told you I've been using router OSPF1. I told you that it's locally significant, right? The reason I'm kind of calling it out is that, for example, the routing process, right, or the OSPF process, it's locally significant. But if we're talking about, let's say, EIGRP, for them to form neighborship, the requirements are a little bit different, right? So, I'm going to use, let's say, 20 here. And once I do that, I could say router ID is 1.1.1.1, right? Now I could do show IP interface brief and say exclude unsigned. And in here, I could now say network 172. Let me do this first. 192.168.12.1, 255.255.255.0, area 0. All right, network 192.168.13.1, 255.255.255.0, area 0, right? So I am expecting, by the way, I'm expecting that router 1, it will have 2 neighbors. It will be neighbors with router 2 and be neighbors with router 3, right? And notice, I just saw that the neighborship just formed, right? I could actually go back and take a look at this. Let me get back to my pen here, and I could just go back and take a look. And here, if I go show IP OSPF neighbor, it's saying, hey, Norwin, you just formed 2 neighborship, man. And here are the neighborships that you form, and here are the IP addresses that you form the neighborship on. And these neighborship are formed by way of these distinct interfaces. All right, now we're getting ready to wrap up. All right, so let me go over to PC1 over here, and let me configure an IP address, which is 172.16.0.10. And it's 255.255.255.0, and the default gateway is .1, right? Now, pretty much the same thing. If I go back over here on my router, on my PC2. Let me go to PC2 over here. And if I say, hey, I want to ping, 172.16.0.10, right? A matter of fact, I'm going to make it continuous. It's just a little bit different in Packet Tracer to do a continuous ping. So he's saying, hey, the destination is unreachable. This is a new one. Destination is unreachable. Aha! Now you see what's going on here. Destination is unreachable. Now let's go over to router 2 and let's see why. If we go over to router 2, why did I jump to router 2? Because I'm on PC 2. And if I look at the topology, PC2 default gateway is router 2. So now in router 2, IP route, if I do show IP route, I am trying to go to a network, right? What's the network that I'm trying to go to? 172.16.0.0/24. And router 2 doesn't know anything about it. It doesn't know anything about it. So it needs to learn about it. And how do we do that? We need to inject it into the OSPF routing process. How do we do that? Well, if you look over here, show run, notice I'm on router 1, show run, section OSPF. I deliberately left it off, right? So notice I am not advertising that network, because if I do show IP, interface brief, exclude unassign, notice I deliberately left it off. So the same thing applies here, by the way. I would go into my router, into the OSPF routing process, and I would say I want gigabit 00 to be passive. All right. So if I go router, OSPF, I think it's 20, right? And I want passive interface to be gigabit 0/0. So that's why. So therefore, it will never send hello messages over there, right? And then what I'm going to do is I'm just going to say network 172.16.0.1 255.255.255.0 area 0. The moment I hit enter here, right, what's going to happen? It's going to start advertising. Once it starts advertising and the advertisement gets over here to router 2, which is the default gateway, right? Which is the default gateway for PC2, then it will start pinging. And look, because it no longer can say that destination host unreachable. Because if I go back and do the same show IP route that I ran before, it says, you know what, Norwin, I just learned about a new network, man. And I actually learned it 25 seconds ago, right? And the new network I learned it by way of OSPF, 172.16.0.0/24, right? 25 seconds ago. So now I know how to get it there. For me to be able to get it there, I need to send it to the next hop router with 192.168.12.1. Y'all see that? Right. So now the ping will happen like this. Right here, get here. Then it will send it down here and boom, get to this PC so that the PC can reply. Right? So what did we do? Or what did we not do? Right? We did a lot of things, guys. So I introduced you to OSPF, right? We walked through kind of, it's a review, I would say, of configuring, interfaces on routers, validating layer 3 connectivity between our routers, coming up with a good kind of lab design, which helps us to identify our routers and networks when we're troubleshooting, right? I also kind of gave you a little bit of some information that I think is important, for OSPF, like, it's a dynamic routing protocol, the administrative distance, it's vendor agnostic, so on and so forth. And I also even went on to show you how OSPF goes about automatically assigning a router ID. And if we chose
not to go the automatic route, we can easily hard code our own router ID, which is what I recommend, right? And then we configured everything, in terms of PC, and we test connectivity across the entire network. We did some debug commands, um, just to see what's going on. I like to tell my students when we do debug commands, we're taking a look under the hood, under the network hood of what's happening in our environment. And those debug commands actually revealed a lot to us, right? In addition, we looked at how we could exclude interfaces that will never form OSPF neighborship from sending broadcasting OSPF messages or hello messages in the network, which is actually just using up resources for really no reason whatsoever, because we'll never have a neighborship form there, right? The last thing that I'll do is I'll just, let's put it over here, right? On router 3, I'll just go in and I'll just introduce this loop back and introduce it into the OSPF routing process and see whether or not we could ping it. So I'm just going to go over to PC1 over here. And once I go into PC1, I'll do 7.7.7, and let me just see -T so I can do a continuous ping. I'm going to put this right over here that says please like and subscribe. I'm going to cover that up for a little bit. I'm just kind of relocating this so we could see the entire picture. So while we work and seeing that, let me look. It's pinging. That's not getting advertised in the network. So what I'm doing over here, I'm just going to go. Going into global config. I'm going to interface loopback. Let's say 7. I'm assigning IP address 7.7.7. It's at 7 255 255 255, and I'm going to say that 255. Right. I'm going to go in the OSPF routing process. I don't remember what that is, so I'm going to say section OSPF, and I will say okay, it's router OSPF1, and I'll just advertise it 7.7.7.7, and I'm going to say 255 255 255 at 0. No, not 255. I'm sorry. Area 0. And the moment I did that, and it gets advertised throughout the network, you will see it starts pinging. And look at that. Right? It starts pinging. So, yeah, that's, guys, the way you're going to get good at this is just by practicing, and practice some more. Remember, I like to say, a lot of people say practice makes perfect, but I look at it and say practice makes permanent, but perfect practice makes perfect. I know some of my viewers and subscribers are students that I teach at a university level, right? So they will always hear me say, perfect practice make perfect. For those of you out there that are watching my videos that I've never met, thank you for watching. Please like, subscribe, and share so I could keep this material coming. Thank you very much, and I hope this was beneficial to you. Bye.